Hello, everybody, and welcome to the Grid Edge Strategy Guide. I'm Joyce Deuley, Senior Research Analyst here at Zpryme. Really looking forward to our conversation today. We have Andrew Kling from Sentient Energy joining us, Shaun Hoyte from ConEdison, and Cameron Freberg, Austin Energy. So let's give them a round of applause before we get started. So one of the big tasks that I asked the panelists to do is just to kind of think a little bit about, what their opening thoughts are on the future of the grid. And I would love it if maybe Andrew could kick us off.
Testing. Good afternoon, everybody. Andrew Kling from Sentient Energy. My title there is the Technical Director of Analytic Services. If you're not familiar with Sentient, Sentient's been around for roughly 10 years. They sell distribution line sensors for overhead and underground fault detection, analytics, and we also have a grid edge control for voltage management. So kind of a diverse product line, but my role there is really taking all the data that we create on those sensors and turning it into actual insights for our partners. My background is actually in the utilities. I was at Duke Energy for 11 years, working on distribution operations, analytics, and some emerging technologies. But back to your question, the future of the grid, I really think the grid's all about creating and processing data. Gartner did a really interesting study where they said by 2025, 75% of the data being used in enterprises is going to be processed and generated outside of the cloud and traditional data centers. So I think that's a really interesting problem specifically for utilities because we have legacy DMP3 systems, communication protocols. A lot of utilities are using public LTE or sometimes private LTE, sometimes mesh networks with latency issues. But with all this data being generated and the concerns of grid edge, really proliferating, how do utilities gather this data and do something meaningful with it? So I think really the challenge that's in front of the industry is gathering that data and creating actual insights from it.
Great. Thank you so much. Shaun?
Good afternoon. Hello? Does this work? Yep. Good afternoon, everyone. Shaun Hoyte, ConEdison. For those of you that are not familiar, we are the steam, electric, and gas energy utility in New York City. It's the 5 boroughs in New York City and Westchester County. About 10 million customers we serve. And my role is in the energy efficiency and demand management department. I started my career there 15 short years ago as a general utility worker working in the field all across the distribution system. I remember my first project was the demolition of White Plains Substation. It was February 12, 2007, freezing cold. Never knew I'd be sitting here telling you I still work for ConEdison today. But from there, I learned so much about just the way the system operates. From that project, went to build several substations across our service territory. That was kind of the model back then, is build to meet demand, not build for efficiency. Right, so we built several substations, and then there were some emergency projects that came in light. My crew was the one that went on site as well. We had Hurricane Sandy, which is one that most of you are familiar with. Steam generating station on 14th Street. We had a transformer that exploded. It was me and my team that replaced that transformer, and then the company invested $1.2 billion in storm hardening to make sure that those sort of infrastructures are protected. So I did a lot of that work for about 8.5 years early in my career. Then I transitioned to the energy efficiency space where, oddly enough, my first role was to defer the build of the same substations I was building as I entered the company. Right, so that project was called BQDM, the Brooklyn Queens Demand Management Program, which we probably will talk a little bit about more later. From there, I went on to manage the small to medium business energy efficiency program, which I still manage today. And then another role, which I'm wearing kind of 2 hats here, which is widespread cross-sector collaboration across all clean energy networks. Where I see the grid going is unique. It's very much more green than when I started the company, and it's promising. I think that we're relying heavily on our customers to be an integral part of the clean energy transition, and it's going to take, again, all of our efforts collectively, collaboratively, to make sure that we're successful.
All right. Lord. Hello, my name is Cameron Freberg. I work for Austin Energy, the municipal utility here in Austin, Texas, if you couldn't tell by the name. I have been there about 10 years now. I just passed the 10-year mark and previously worked at CPS Energy in San Antonio before coming here. Yep, nice, woo-woo. And in terms of where the grid is going, I think that one of the biggest transitions is, I'd say 10, 15 years ago, I don't think that we as utilities cared about anything beyond that meter. It was all one-way flow. It's like, okay, generate it, figure out how much we need, and then send it out, and then measure it, and then charge somebody for it. Now, my job and a ton of my colleagues, pretty much jobs exist because of the other side of the meter and the dynamics that are associated with that. So I've heard it once described as in terms of the future of the grid is it's going to completely change to all distributed assets, and you're never going to know it because it's going to happen so gradually. And it's going to be driven by things like data, by smart controls, by customer adoption, by all these things utilities did not do for the last 100 years or so. And even though we just talked about background for a little bit, I didn't think 10 or 12 years later I'd be saying I work at a utility. My background is in advertising. Then I realized I'm terrible at that and went back and got a degree in urban planning and got a degree at a utility. So 12 years later, here I am. So.
Excellent. Yeah. So I think we have some really diverse panelists here with really interesting perspectives. And because the grid is a little complicated and a little abstract of a concept, I'd really love it if we could define what exactly the grid is to you. Cameron, kick us off.
Yeah, so in terms of the grid, and more specifically what the grid edge is to me, like I mentioned, it's just I don't think there was much of a consideration for the edge of the grid, or that the meter was the grid edge for the longest time. It's like, okay, well, we send it out and we have a way to measure it and pay and charge for it, and that's it. Now, to me, when I think of the grid edge, it's all of those devices, and primarily customer-adopted devices, what I think of a lot of it, and the controls and the value that can be taken out of those things, from everything like, thermostats and demand response aren't a new thing for utilities. It's been around for a long time, but I think that kind of set the standard for a lot of how you get value different ways now from these devices at the edge of the grid. And so everything from more devices like smart thermostats, ultimately battery systems, and then, of course, electric vehicles and the growth here. We have 15,000+ of them here in Austin, and I'd say not more than 10 years ago, I think we were excited when we passed like 200 or 300 here. That was a crazy number. So, when we're talking about hundreds of thousands of these devices out there that can do two-way flow, I think of us carrying now to a much more granular level beyond that meter into like what customers are actually adopting. So.
Thank you. Andrew.
Yeah, I think that's a great perspective, Cameron. When I think of grid edge technologies, I really think of more of an ecosystem. So it certainly involves the devices behind the meter, DERs, storage. But I also think of the devices kind of in front of the meter and the software and infrastructure that's needed to make that data and those devices useful. So it's an ecosystem. That encompasses things like potentially microgrid controllers, where the edge of the grid is less defined. You might have dynamic microgrids in the future that rely on both behind the meter assets and utility assets. So I think it is a fuzzy term. It's hard to pin down exactly what it means, but I think it's that combination of behind the meter and in front of the meter assets, along with the software applications to control them.
Excellent. Thank you. And Shaun.
I think this is I'm going to summarize sort of my interpretation based off of Cameron and Andrew's description. So I was watching Jason in his opening remarks yesterday, and he's speaking about power up and how gaming has transformed and evolved and how it's very comparable to our energy landscape. And I was thinking to myself, what is the grid edge, right? So it's a combination of technologies and sort of services provided to our customers. When I stepped out the elevator yesterday, I was just telling Joyce today, let me talk third so I can summarize this in a way that makes sense to me. It's that game of Pac-Man just resonated with me, right? We all know the game of Pac-Man, right? So Pac-Man or Miss Pac-Man represents the customer, right? You have the maze, that's the grid, right? Then you have those dots that are electrons that they're eating up just to survive, right? Then you have those 4 blinking bigger dots that represent the grid edge and these analytics, these tools, these physical assets that they could take advantage of and take control of their energy future, right? So I'll give you an example. Level 1 would be a large commercial customer that has capital, that has a team, a staff that could really take advantage of the grid edge, right? The level's fairly easy, right? They can navigate through the maze without really getting attacked by the monsters, which represent different challenges for these different market segments, right? So without those sort of capital or that experience, you get to a higher level, right? Think about a small business customer in an LMI community or environmental justice zone, right? That level is extremely hard. They may not even be able to get to those blinking dots to unlock the true value of the grid edge, right? Because those monsters are coming after them. It could be the pandemic, it could be supply chain, it could be just day-to-day revenue streams that they don't have, right? The accessibility, it could be the digital divide. How can you take advantage of things on the grid edge if you're not connected with broadband or any sort of capacity where you could take advantage of those resources? Then you think, so I kept doing research. I was in a dark rabbit hole of Pac-Man last night, right? And it goes up to 256 levels. At that point, it just crashes. It's an unbeatable game, right? It fizzles out and you can't beat it. I think that market segment are the communities that have been historically disadvantaged, that aren't able to access any of these resources. Think about indoor air quality, outdoor air quality that they're suffering from because of what we have put into the ground. Right, so when I look at the grid edge, it's having the ability to take advantage of those blinking dots and running away from those monsters and having the ability to tackle those monsters head on with the values that we're unlocking at the utility level, at the software provider level, at the distribution level, all across the value stream.
Boom. Thank you. Yeah, and way to tie it into our theme. We really appreciate that. That was really fantastic, all three of y'all's definitions. So because it looks different to kind of everybody as they're touching the space, right, with the grid edge, how is that changing the shape of the grid and moving forward? Cameron?
Oop, I didn't get a boom after my response.
Boom.
There we go. Thank you for accommodating. I think that the big thing is how it's changing is the way that we value what we produce as a utility and the way that we can pass that value along to customers. And a very specific example of the way I look at it is when we did our first battery storage deployment a few years back. That was one of the tasks. It's like, okay, let's figure out every value stream possible with these battery systems. And I think we came up with like 19 or something like that as part of it was the Austin Shines project, is what it was called. And there was no way we could capture value all 19 of those ways, but there were a few traditional utility ways that we could capture that value, and things like demand response or reducing demand charges for commercial customers, things like that already existed. But there's probably a dozen or so other value streams still sitting out there on the table. And there are problems that we as utilities kind of already know could exist or do exist in certain instances, like wind and solar variants or more advanced energy arbitrage in the energy market, and things like that. And even though the capability is not fully there to do all of those things yet, all those distributed assets, the data streams coming in, the ability to control them and kind of have that autonomy of like, oh, here's how we can, as utility, can get value from, reducing demand or doing two-way flows, all that stuff, and then passing that along to customers, and then creating value for our customers. I think that's how it's really changing. Is just, okay, it's not just generation in the ways we've traditionally operated before. It's more like, okay, there's a lot more value to be captured. We can be way more dynamic with these assets now, where they don't have to be just turn them on and off. There's a lot more opportunity that way. So.
Thank you. Andrew?
Yeah, I'm going to draw on my experience from my utility days. So historically, utilities, when they think about the shape of the grid and the investments that they need to make in the distribution system, they have a distribution planner. He's an owner over maybe a couple dozen different feeders, and they'll go and look at the peak current that they saw for each circuit breaker, and then estimate 2% growth over the next 10 years, and do a little bit of analysis and determine if their wire size can be big enough. That's no longer going to be possible going forward. It's much more probabilistic, looking at zip codes, economics, demographics, who's going to own and purchase EVs, photovoltaic for your roof. And that's really shifting the way that I think a lot of modern utilities are looking at their planning. Not only are they looking at distribution planning, they're integrating that with their transmission planning. And through those planning processes, that's kind of shaping the grid. And just one example I'll give of the approach that we were using, we actually forecasted every hour for 10 years into the future what we thought the load for every single circuit was going to be based on economic data, demographic data, probabilistic uncertainties of EV adoption. And then for every single one of those hours, we ran a power flow simulation and we assess, will we have thermal issues with our conductors, basically pushing too much power down the line, or will we have voltage issues where we don't have enough voltage capacity to serve the expected load, or sometimes where we expected high PV adoption, maybe we had too high a voltage and we couldn't accommodate that new higher voltage. So it really takes a paradigm shift in the way utilities think about how they're serving load and the choices that their customers are going to make in the future.
Thank you. Shaun?
Yeah, I'm going to look at it at a similar perspective. Historically, when you look at energy efficiency, it could be a losing proposition for any investor of a utility. Right? Essentially, you're asking a customer to install energy efficient equipment so you pay that utility less. Right? You're not building infrastructure, so there's less revenue for your shareholders. What we learned from the Brooklyn Queens Demand Management Program and non-wires alternatives is that we could defer the build of infrastructure by implementing what we call customer-side solutions. Right? And we did so by investing in $200 million behind the meter, DERs, energy efficiency as simple as lighting solutions for a variety of customers that lived within a specific network that was forecasted to be constrained. So similar to what Andrew mentioned with his utility, we do what's called a 5, 10, and a 20-year load relief plan. And we do that annually within certain departments and groups at ConEdison. And what we established there is understanding where there's load growth and what the potential outcomes could be, right, and how we're going to combat those potential outcomes. So a traditional approach, the most simple one would be adjacent load transfer to an adjacent substation that has capacity that could take on, say, the largest customers onto their load. Other things that are included in the benefit cost analysis would be transformer cooling, right, installing a new transformer, upgrading capacitors. There are a lot of solutions that we could do to increase capacity at a substation, and ultimately, if all those options are exhausted, then we'll build a substation. So for BQDM, it was a $1.2 billion build of a substation that we deferred with $200 million of customer-side solutions. We also unlocked a revenue stream for the utility where we're able to recoup and earn a return on the divestment of that substation. What transpired after that, and that was under the Reform of the Energy Vision proceedings, was the CLCPA, right, the Climate Leadership and Community Protection Act. And now at the utility, we have a framework that allows us to what we call earn, or an earnings adjustment mechanism where we can earn on the deferral or the installation of certain targets that we hit from the energy efficiency landscape. So now the customer is getting more value for their buck, right? We're not increasing rates because we're building infrastructure, right? The utility is remaining whole for the shareholders because we're able to earn a return off that divestment based off these goals and criteria that we set forth. We're regulated, by the way, so the Public Service Commission and NYSERDA, we kind of make sure that that framework is viable for all parties. And now we have a model that energy efficiency isn't just transactional, it's not just for conservation, but it's actually driving meaningful change within our energy landscape. So when we look at the grid again, what we're looking at is full participation all across the value stream from transmission, distribution, to the end user.
Fabulous. Thank you, guys. So, having a background in IoT, when it was all about connecting devices, making sure that your edge is connected and deployed, we're establishing that with the grid right now. Like, we're putting these end devices out there, but they really serve as enablers, right? And so how are they actually enabling resiliency and reliability across the grid moving forward? Andrew?
Yeah, so I think it's helpful to think kind of historically how we've treated resiliency and reliability with devices. So traditionally, if there was an outage on your circuit and you experienced it, you're at home, you'd call up your utility and say, hey, I have an outage. They have paper outage maps or paper circuit maps, and they would use that to determine maybe where your circuit was. And if they were really technically advanced at the time, they would have an OMS system that might do that auto-magically. And then as you progress through history, things like AMI came into existence, and those could automatically report back. And there was, maybe 15-minute delay sometimes. The data didn't get back, but you got enough of that to kind of triangulate where your outages were. Progressing through history, and as we moved more connected devices further out in the grid, you saw things like SCADA-enabled reclosers and trip savers, and SCADA-enabled normally open switch points that allow for if there's an outage on your circuit, you might be able to switch load to an adjacent circuit and minimize the impact of that outage. I think that's where most modern utilities are today, moving somewhere in that direction. But I think we can go even further, and I think a lot of kind of progressive technology companies are pushing the envelope of what they can do with edge computing on their devices. So a good example is AMI manufacturers using voltage data that they get to detect failing transformers. Or an example from my company is we capture waveforms on the distribution line to detect incipient faults to mitigate outages before they even happen. So I think using that edge computing and kind of the proliferation of data capture at the edge is really going to push kind of the next wave of improvements in reliability and resiliency.
Boom. Thank you. Shaun.
Yeah, I agree with Andrew. I think the traditional AMI meter, that's been a topic all week so far. You're getting 12 data points per customer per year, right? Once per month with a meter reader going out to your facility. Now we're at 15-minute integrals for our residential customer. That's about 35,000 readings for the meter. And then at the large commercial customer, we get about 5-minute integrals. Right? So that's over 100,000 reads. So that's a lot of data that we have to work with to make really unique decisions to cut down the time on restoring power. In terms of resiliency, you can't really quantify resiliency until the power goes out and everyone's complaining and yelling and really uncomfortable, right? But having distributed energy resources on site for some of our largest customers allows the utility the flexibility for if we do have an outage, they could kind of distribute that load to the adjacent customers in that neighborhood or in that network and provide us that sort of reliable construct so that we can make sure that our customers are well served. So we really look forward to partnering with those types of customers and incentivizing them to really have that on-site sort of generation. That's sort of what happened in Hurricane Sandy, right? If we had more NYU Langones or more Columbia universities that have cogen stations on site, then a lot of customers that were in outages would not have received those blackouts, right? So we really look for that support. Again, it's the two-way sort of new grid that we're looking at where it's not just generation to consumption and then boom, it's wasted energy, right? It's a two-way flow of electricity and upgrading our network protectors and our SCADA system so that once the energy goes bidirectional, it's not really triggering a fault and opening load so that we can protect our assets, right? It's saying, no, this is supposed to go this direction because we have clear visibility that this customer is sending energy back to the grids for reliability.
Excellent. Thank you. Cameron.
Sure, and Shaun, it's very similar, Shaun. I think of when mentioned reliability and resiliency and how the grid edge will be impacted. I think very much more on the adoption of distributed energy resources and how that will impact it. I mean, there's a lot we're doing to our distribution transmission systems and hardening those up, but like I said, I live on the other side of the meter, so I tend to think those ways. And just the sheer amount of adoption happening of DERs, whether it be through battery systems or controllable assets. I mean, think about what we had in 2020, or 2021, sorry, with Winter Storm Uri here in Texas. That's probably the worst winter event that I can ever remember. And how we did any kind of controls, it was strictly on like circuits, it was just controls of shutting on and off entire circuits within the distribution system, as opposed to like, okay, if you eventually got to a point where you had enough distributed assets out there, it's okay, you can aggregate those, not go through a traditional circuit, and then you can turn on and off disaggregated load that might not be that as critical. And so you're getting a lot more visibility and insight to what you can control and how you respond to those kind of events. The other piece I think of in terms of that reliability and resiliency piece is the individual users. I mean, just with that amount of adoption, things like not having to rely on, say, natural gas or even diesel or gas generators in residential homes or at multifamily properties, things like that, and having battery systems, and just the way that backup generation now happens and the ability to connect that to circuits and all that stuff is completely different than it used to be. So I think there's kind of two plays on it. And the third one is kind of backup generation in terms of like electric vehicles and how that's going to ultimately kind of come into this and what vehicle to grid, vehicle home, all that actually looks like. I have a couple of colleagues here that basically have been tasked with putting in all of the charging infrastructure you see in Austin, and now the questions are coming up. It's like, okay, well, we're taking our whole transportation sector and putting on electric. What does reliability, resiliency, and kind of backup options for that look like? So that's when we have to start thinking of things like, okay, how do you insert batteries into those? How do you insert kind of a secondary generation that powers your transportation sector now? So we're taking a lot more responsibility on, it seems like, into areas that we never thought we would. I don't think 20 years ago the utility industry thought, oh, we're going to be in charge of the transportation sector's fuel. to in the entirety. So now you have to think of ways to do backup generation for that area as well. And not just that, but the amount of load that these things are serving now is the magnitude is pretty high. So it's not simple as like backing up a residential home. It's backing up 10, 20, 30 megawatts of a transportation sector in some instances. So
that actually like brings up the next question that I have really wonderfully, because like, you know, it's not just about getting those things out there. It's not just about how it's starting to change, you know, the customer experience or how it can add reliability to the grid, but like there's business models that are being impacted, and you're having to think about new business lines like moving into the transportation sector in a way that you haven't before. So let's talk a little bit about how those models are being impacted, or which models specifically should change as a result. Cameron, why don't you go ahead and...
Sure, and I'll go ahead and start off with the transportation electrification sector and just the way that kind of utilities have typically viewed assets. And you know, when you're doing things like either rate making or trying to figure out what the value is that coming back in, a lot of utilities historically might look at that one asset or one group of assets, figure out what the cost of that is, and figure out how to set rates for an ROI. For electric transportation, there's a whole lot of variables in it that make it a little bit more difficult to do. A is in terms of that kind of load. If you look at things like, you know, level 1 overnight charging when in like Texas, when wind is quite abundant, or you know, there's plenty of room on the grid to charge all these vehicles. Okay, well, what kind of rate structure would accommodate kind of charging that? Is it a time of use structure, or do you have kind of more dynamic rate structures that are driven by data that can kind of you know, change when somebody charges? And also, when you're looking at like assets, I talk about how utilities might tie valuation to assets and set rates for that kind of stuff. I think of like a charging network, right, where utilities historically might say, okay, well, we're spending $1 million in these assets, put them out there. In order to recoup that cost, we need to set rates at, I don't know, $5 an hour or 50 cents a kilowatt. These are just arbitrary numbers, and trying to figure out how to recoup that asset. For things like EVs or even batteries, it's like, okay, well, your value doesn't come just from putting that asset in the ground. Now, it comes from the life of having that vehicle out in your community now. If it can charge overnight, it's the traditional kilowatt hours that come in over it. So it's a lot more complicated of figuring out, okay, what's the ultimate value of those assets now compared to just like connecting something to the grid and knowing when its usage is going to be. And a big thing about that, and here in Texas, why it really matters is, unlike everything else in Texas, EVs aren't going to be temperature-based in terms of when they draw. I mean, when it's 105 in August, EVs are not really susceptible to, okay, we're not going to charge them at 5 p.m. or 7 p.m. in August. So, and I apologize. I talk really fast sometimes when I get excited. So I can see a few, and that's typically me talking very, very fast. So
That's okay. That's what the questions are for. Yeah. Shaun.
Yeah, I want to take a different spin on electrification. At ConEd and in New York, we are 100% committed to electrification of fleets and vehicles. But another key driver is electrification of the heating and the domestic hot water in the winter. Right? So we have a statewide clean heat program where we've identified, at least within New York City, that we have 40% capacity to build in electrification of heating systems. Now, those same systems, you have the furnaces for fossil fuel-based boilers and domestic hot water equipment accounts for about 40+% of the carbon emissions in New York City alone. Right? So all of these efforts to green the grid and for the grid edge is really centered around the decarbonization efforts, so that we could reduce carbon and the planet could be in a better position than it is in today. Right? So the challenges there are, heating in New York City is a necessity. Right? It's something that we have to provide to all of our customers. Building owners, landlords, they have to include it in the package. It's something that you can't live without. Retrofitting to heat pump technologies isn't the easiest solution, but it's the most efficient solution that we can provide to our customers right now. Right? So designing the system in a way that our contractors are not oversizing equipment. When you think about traditional heating systems right now and cooling, they're all oversized, right? Because they're designed to heat and cool an entire building, right? Not in temperature zones, right? Which is more efficient and effective, right? And when you think about the specs, I think they may be spec'd to 10-degree days or 5-degree days. There may not be that many 10-degree days in New York City. I can't remember how many we had last year, all right? So right there, you already know that they're being oversized. And when you combine that with the building envelope that is just leaking all across our building stock, right, it makes it very hard to quantify exactly what we're going to put into the ground. So setting that rate, the incentives for for the different market segments, you have the residential segment, you have the multifamily segment, small to medium business, and large commercial, is a challenge, right? And having the customers even understand how to use the product correctly. You know, we have a lot of residential customers that are purchasing heat pumps and using them just for air conditioning. They're not disconnecting their heating system in the winter. So really, we're not electrifying the heating load at all for those customers, right? So setting the incentive level in a way that you're rewarded for one, for the heat pump, right? That's the carrot. We're giving you incentive for that heat pump. And then when you take the next step to disconnect your current heating system, and then in addition, add building envelope will unlock another incentive level, has really driven the market so far. But we're still looking for solutions. It's not only to give incentives to our customers, but it's getting the right manufacturers to create and develop the right products, right? So we need cold climate heat pumps, not just your heat pump that you may install in Florida, right? Because it won't be efficient in the Northeast region. So those are some of the electrification efforts that we're heavily focused on. At ConEdison, we're investing $1.5 billion in electrification and energy efficiency as an interim target by 2025, and then tripling those efforts by 2030.
Yeah, and that's a really great lead-in, and I think Cameron and Shaun both touched on it, is that in order to achieve deep decarbonization, electrification is a necessity. And when we talk about electrification, especially electric vehicles, if the power is not there, you're not going to be able to charge your car, you're not going to be able to go to work. So it's going to start deeply impacting people's lives, the impacts of poor reliability and poor resiliency. And I think we're already starting to see kind of a fundamental shift of utilities investing in assets more on the distribution grid than the transmission grid. And I think that's going to start to continue more on a focus of resiliency as customers start complaining about their electric vehicle not being charged due to, run to failure, which is the typical way a utility would treat distribution assets. If a distribution transformer's been out there for 25 years and it shows no signs of, outward failure, no reason to replace it. Typically run it to failure. Customer experiences a minor outage, but they can go on with their lives. But as we continue to electrify more and more behind the meter, I think you're going to start to see the customers demand better resiliency and reliability from the utilities.
Excellent. Thank you so much. So that actually kind of moves into the final question that I have before we start taking audience questions. And it looks like we have a good group of people, so hopefully we'll get some great engagement. Speaking about the customer, what is shifting in the customer space as a result of implementing these solutions? And what's the responsibility of the utilities and the vendors on behalf of the customers? Andrew?
Yeah, I think customers as a whole, and this has been kind of a theme throughout the conference I've noticed so far, is customers as a whole are becoming more interested in their sources for energy. They're asking questions about decarbonization. There's just a higher level of engagement and tech savviness on the whole, and I think it's becoming evident in the way customer programs are evolving at utilities to be more focused on that customer feedback, on the equitable treatment of customers. So yeah, I'll leave more time for my utility panelists because they probably have deeper insights there.
Excellent. Cameron?
Sure, and I'll try not to spend 20 minutes on this question. I'm really a big fan of that because the number one thing that I think this changes is the relationship that we get to have with our customers and the relationship they get to have with us. I mean, traditionally, even though we provide a very necessary resource and thing to live, electricity, the relationship has basically been, I'm calling you to set up service, I'm calling you because there's an outage, or I'm calling to disconnect service, or I'm paying a bill. Not exactly the four most positive interactions you're going to have with as a customer. Now, with the adoption of like distributed energy resources, and now with things like providing incentives for solar or energy efficiency programs, and like you mentioned, customers want these things now in terms of like whether it be higher levels of renewable energy or going green, or actually having these products in a smart home. We now get to be a service provider for a lot of things that customers want, and that customers get to choose themselves and be that service provider and subject matter expert for them. Like I mentioned, some of my colleagues that do the charging infrastructure, it's like the utility is doing vehicle fueling infrastructure, and we get to be a service provider for things like that and a trusted resource. And it's just a completely different dynamic as an electric utility to have that relationship with customers and kind of build that trust for these assets that are ultimately coming. So, I think you have to kind of maintain that trust for customers to want to engage with you, but I feel that our adoption and our programs is kind of a good sign that we're maintaining that trust. So I think that's, a big difference from 20 years ago probably. So
Boom. And
the boom is appreciated.
the boom is appreciated. Shaun, would you close us out, please?
I think we could leave it at the boom. It's really exactly what has been mentioned, is that relationship with our customers, just building that trust and having them know that we're here to help them all along the step of their journey, right? It's a partnership, right, that we're looking to develop as we face these challenges together. So I think that my panelists, they summarized it very adequately.
Thank you. I think all of you have done a great job. So questions, opening it up for questions. Anybody have any questions for our wonderful? Yes, sir.
Hi. One of the things I'm interested in as you talk about sort of the proliferation of all these DERs, we also know that not everybody can afford to pay for a lot of these assets to have them in their homes. And I'm wondering, especially for the utility folks, if you've looked at a model where the utility actually owns those assets and actually provides them to the end users partly for their own use and saving money, maybe through energy efficiency, but also or increased reliability in the case of, like, say, battery storage, that type of thing. But also, of course, that does provide additional sort of system-wide value that we've been talking a lot about. So I'm just curious if that's a business model that you guys have explored at all. And examples would be maybe heat pump water heaters and battery backup batteries.
Yeah, I'll take a stab at it. So we have a number of participating contractors in a statewide clean heat program, and some of them is called energy as a service or energy efficiency as a service, have taken on that model. Block Power would be one of the contractors that people know most about that has that model within our program. We also have other PCs that offer that, and basically what they do is they provide funding for the assets, crowdfunding to purchase the product, and then they offer it to the customer. The customer's bill goes down, and as it goes down, that's how they pay back the contractor, right? So the customer's not seeing any change, no out-of-pocket expense, but they're seeing the benefits of the system in their facilities, right? So that's an example of that. We also have a couple of others in our core energy efficiency programs that have that same model, right? They have a number of businesses across our territory that they take over the actual ConEd account bill, right? They keep their bill flat so it doesn't go up, but as it actually goes down, that's how that contractor gets paid, compensated for the equipment that they install at the facility until it reaches parity. Then they start to share the benefits of the cost reduction over time.
Yeah, and I mean, the short answer is absolutely, we do both. It's because when you talk about distributed energy resources, I mean, you're talking about a whole host of different things, and they do get lumped together a lot because that's what they are. I mean, they're distributed, they're energy resource. But when things like rooftop solar versus battery storage versus electric vehicle charging, and then the different use cases for each one are like, whether it be on the residential level, commercial and multifamily customers, industrial, or on the grid side. So, I mean, among all those, and I'll use like batteries and EV charging as an example. Like, there's certain areas where customer adoption is going to happen. The market's going to take care of itself for certain instances, right? Like, you might have high adoption, but it might only be in certain parts of your city. It might be just from affluent customers. And then how do, our role is, and we're not just utility, but we're also local government. So how do we serve, all of our communities, and how do we kind of fill in those gaps where that might not happen? And so from a battery side, even though battery adoption is relatively early on, we worked with some customer adoption customer adoption side of things, but we'd also done some kind of grid level applications of putting it out there to either strengthen the distribution system at the circuit level, things like that. So we've done both models of that, and then also on like the EV charging side is while a lot of communities and a lot of like properties are installing EV charging and making that available and partnering with us, there's a big part of Austin that still hasn't done it quite yet, and so how do we either take and own part of that to make sure like every community has access to these resources? How do we partner with them to either increase incentive levels to reduce that kind of capital burden of putting stuff in? So there's no target. It's really looking at like, okay, what's the adoption uptake of these things, and then how do we kind of either fill in those gaps or accelerate adoption in different areas? One of the examples I'll look at is that's constantly, I won't say it's a barrier, but it's a lot more complicated, is how we work with the multifamily sector. Because it's a shared resource. They're constantly looking at like monthly ROI and how to make payback, stuff like that. So they're not typically the early adopters for a lot of these for DERs or even like things like community-wide Wi-Fi. And so there's a lot of stuff out there like where we as a utility and local government can come in and either fill in those gaps or accelerate adoption in some of these sectors that, might not be early to adopt it. And basically half of Austin's multifamily. So by not kind of catering and helping grow that sector, we're ignoring half of our customers. So luckily we do keep a close eye on that kind of stuff.
Yeah, I can't speak directly to customer programs from a utility, but I do have some background in research for emerging technologies, and one of the things we were investigating was exactly that, bringing your own battery or supplying a power wall to a customer, and what's the economic benefit to the utility, and what's the effective value to the customer if you had different levels of discharge capability for the utility. And what we found was the cost to install a power wall, roughly 30 to 50% of the overall cost was just installation costs based on new electrical work being done in the house. So what we found is actually partnering with home builders on new build homes to properly site and install that energy storage or those EV chargers on the upfront side, and build in things like high R value insulation and build towards that net zero individual building goal. The more you can do on the front side, the cheaper it's going to be and the more cost effective for both the utility and the end consumer.
Can I ask a question about microgrids? Sure. Hudson Yards is probably well known as one of the great microgrid experiments. What has Con Ed learned about it, and what is Austin Energy doing about microgrids here?
Yeah, I mean, it's a good one. It's a smart city within a city is what we call it, right? And we're looking to really promote more of those sort of build-outs. We're seeing a lot of new construction in the outer boroughs. That's Brooklyn, Queens, just outside of Manhattan. And Hudson Yards is a testament of what one of those cities could look like, right? It's unlocking the grid edge, right? So you have devices in the apartments there. Think about your dishwasher that could really see the pricing signals and when it should be turned on and off, right? So you're not getting charged demand charges for running your dishwasher midday. Other things that we've learned from that is the type of load that we need to provide to an area that's looking for that build out, right? It doesn't take a little bit of work. There's a lot of work involved in that type of a build out, right? It takes years of planning and the right developer and the right partners, right? So we're looking for more of that build out. A lot of it is looking like it's coming in Brooklyn, right? And as we start to look at, again, that 5, 10, 20-year load relief plan, we're making sure that our system will be able to accept some of those new features.
And in Austin, I'll say the same thing in terms of the difficulty of doing it and having the right kind of use cases. It makes all the difference. I mean, our best application of that is something in the Mueller neighborhood, even though it's connected to our local distribution grid. The Mueller neighborhood is the site of our old airport here in Austin, and it was redeveloped, about 15 or so years ago with a lot of the idea of either creating a lot of connectivity of devices and somewhat of a microgrid out there at that site. But it was built with all that in plan. There was no retrofitting to that. And so, the amount of lessons learned for that are, for instance, all of these devices and having all these different applications kind of centralized into an aggregation system, or getting, not conflicting data sources, and having all that kind of even open standards for all these things to be interoperable together. That is a huge barrier. I mean, we've learned that not just with different partners in the same industry, so not with just multiple providers of one kind of asset, whether it be thermostats or EV charging, whatever. Having them talk to each other is hard enough, but then having that kind of communications protocol across all those assets into a centralized platform is way even more difficult. And then connecting the data streams to get them to autonomously do things is even more difficult on top of that. So, I do believe it's going to happen, and you're going to start having a lot more of that kind of interoperability happening. And so right now, we're just trying to figure out as utilities, what are those sets of standards we want? What does that interoperability look like? How do we want all that to interconnect with our actual grid? Because even though we'll support those things, it's not going to necessarily take the place of the grid. Is going to be it's going to be interconnected with it. So there's tons of lessons learned, and just like setting standards of what you want to see in your kind of territory is, I think, where it's really at. So.
Yes, ma'am.
I have a question going back to customer trust. How do you build customer trust / resiliency with the energy burden community? Especially, you mentioned Fury, issues up in New York, and district snowstorm. How do you guys approach the community and build trust?
Yeah, I'm going to take it right back to those widespread cross-sector collaboration, right? And that's working very closely with the CBOs in the area, right? The community-based organizations, right? That have the trust of that community, and educating them, letting them know exactly where these pricing signals are coming from. Think about back in January, the fuel charges were so high, and that was a direct pass-through to the customers on our distribution system. Now, what the customer sees is my ConEd bill went up 3 times the amount, right? We have very little control over that because we don't operate in the retail market, right? Those prices are set at the NYSO level. That's the New York Independent System Operator. So again, partnering with those community-based organizations, the chambers of commerce, right, the business improvement districts, to really educate them, they have the trust of their customer base and help them understand that we're there to help them, right? And we have other solutions for them to help them navigate through these challenging times.
And on would help. In terms of like the solution for something like as disastrous as that, I mean, it's very hard to maintain that trust. I mean, but the thing that we have the most control over is our communications to our customers and putting in those assets, like things like our outage maps and things like just knowing, like what the durations and locations and all that stuff in real time are going to be. That's one thing that we have high control over, and that we can work with our customers to do. And just being extremely transparent, whether it be good or bad news. I mean, that's really what that's what I want as a customer is like, hey, if it's going to be 12 hours, let me know it's going to be 12 hours. Or if it's this, if it's just me, or if it's 600 of my closest customer friends over here. Just having that kind of transparency, knowing that is the thing that we have high control over and can build that trust. But when you have like catastrophic events like that, we're the service provider, and whether it be a fault of our own or just of circumstantial, I mean, we're still that connection point with our customers. So we have that burden to be as open and transparent as we possibly can with our customer base. So,
Andrew, do you have anything to add?
Not having direct customers that aren't utilities in my current role, but speaking to my previous role at a utility, one of the things that I think they did really well was connecting to customers through demonstration sites. If you can make something real and tangible and understandable to a customer, I think you build that credibility and that trust. Obviously, that's not a completely equitable situation. People still have to arrive and have the time and time off work to go there. But I think it's a step in the right direction. And the more you can bring those sites to people where they're at, rather than having them come to you, I think you kind of build that trust through just making your operations as credible and understandable as possible.
Amazing. Thank you. Can I get another round of applause for our guests, please? If you do have additional questions, please feel free to come up to them and talk to them. I'm sure they want to talk to you. Thank you so much.
And we went overtime and almost nobody left.
I know. Woo!